systems. So the next ones we're going to get into is the drainage systems. And then going back to the beginning of the supplies system, remember, even though I want you to know the 20 to 80 psi is, acceptable, I want you to know 40 to 70 is probable what we're going to end up seeing. I want you to know that under 20, you need a pump. Over 80, you need a pressure reducing device where it comes in there. We still work with functional flow. So I do want you to know the definition of functional flow, and this will keep you out of trouble. I can't tell you how many times that when we run the water and just the hot water only, especially in showers, you just get a ridiculously low water flow. You turn the cold water on, and everything looks beautiful again. But you're going to end up taking a cold shower there. That's the problem. And most people like to take a nice hot one. So when we're dealing with functional flow, that's water coming in. When we're dealing with functional drainage, that's water going out. And it's a simple rule. Anything should be draining water as fast as it comes into it. So if I'm in a tub and I got the water running from the spigot or the shower, and by the time I get to the end of my shower, I'm ankle deep in water, that's not functional drainage, all right? Now, if it fills up a little bit and then it holds it right there, that's still functional drainage, but it's most likely those lines are going to have to be cleaned. So waste piping, refer to it as drain waste vent. Drains, they end up taking from the sinks, and that usually includes the traps. The waste lines are going to be our main plumbing lines that take away our solids and our water. And then the vent lines allow gases to escape upwards. Plus, they also allow air to enter the waste lines so that it prevents everything from creating siphons in our waste lines and allowing sewer gases to enter the building. All right, we'll go over those in a little bit greater detail right now. All right. So common materials, and we do have to describe the materials. Actually, this brings up a good point, too. We take on the term home inspector, all right? And in the state of Illinois, we have an Illinois plumbing code. And I do want to be very clear that only licensed plumbers are allowed to inspect plumbing systems, all right? We are not licensed plumbers. So technically, we're not allowed to inspect the plumbing system. Now, the Illinois Department of Financial and Professional Regulations, they realize that if we don't do something or look at the plumbing system and give somebody some sort of idea that there's a problem with it, that we're not protecting the public. All right, and that's their battle cry. Is all the licensees, their job is basically to protect the public. All right. So if we say home inspectors aren't allowed to inspect plumbing systems, well, that puts the public in pretty good harm should there be anything wrong with plumbing systems. So I'm going to do another one of these sessions on the SOP where we'll pull that up and we'll show it. But there's nothing wrong with you going there and reading it as well. What they did was they reworded it. And they say what we have to do is describe in detail the plumbing system. And that includes the supply lines. That includes the service lines, the waste pipes, the drains, the vents, everything else that comes with it, and issues that we find with those as well. All right. So what we want to do, and I don't know anybody who's gotten in trouble with this yet, nor do I think they will. I think the IDFPR will defend us for what it's worth. But if we know the rules, let's just stay within them. All right. So in our reports, let's try to avoid saying the plumbing system was inspected or, I couldn't inspect it because of this. Try to use whatever our state law says, which is that describe in detail. So we do have to describe in detail the materials that we're going to be using. Part of those is going to be, the drain piping, the waste piping, the vent piping. So typically cast iron, copper, PVC, those are the ones we're going to run into. All right. So the first one we're going to deal with is cast iron. This is showing a hubless connection. So there's no bell, no gusset. Typically, if I have to cut the pipes and stack them on top of each other, this is how I'm going to make that connection. Gravity is going to hold these things together. We have a community up in Lake Forest that up until like about the last 5 years ago, every waistline in that house had to be cast iron, up to and including the trap for sinks, kitchen sinks, bathroom sinks, toilets, everything had to be cast iron inside that house. That was a waistline. Finally, it's gotten overturned, and now they're going to go ahead and let PVC come into play. I mean, as far as I'm concerned, PVC is terrific. But our biggest concern when we stack pipes here is these things sliding on top of each other. So what they do is they put a corrugated metal band around it with a rubber seal to keep it watertight, and then we put the compression clamps on it just so nothing can get away from it. But most of the time it's going to end up being a bell and gosset type situation. So we're going to have that bell that's going to hold the other pipe on top of it. It's going to sit inside of it. And then they're going to stuff the lower level of that gap with a waxy rope. And that waxy rope is called oakum. And then they're going to take lead and they're going to heat up that lead and get it into a liquid form. And they're going to pour that lead on top of the oakum in that gap, and that's what's going to make our watertight seal. Sometimes that oakum will start to boil, and then that'll come up and over the top, and it'll look like there's brown stains that are coming off of that gap, all right? And if you don't know what you're looking for or don't recognize it right away, I can honestly see how somebody would think that that's a leak at that joint, when in all reality it's oakum, all right? Other than looking at it, the only other test I know to make sure that it's oakum is very sweet tasting. So if that's spilled, no, please, I'm joking. Don't taste the oakum. There is no other test. I apologize for doing that. All right, drain waste piping again. Let's move on. Proper pitch is important for good drainage. This is a test question, and I know one of our field houses that we had in the south suburbs, we were looking at waistlines that were going on almost a 45-degree angle. You know, we had some of them that were going up as well. So the proper pitch is important. I do want you to know 1/4 inch per foot is the acceptable slope of this stuff. The blue that you're seeing in these drawings is water. The brown little pellet things is poop. And if you have it too shallow, the poop and the water is going to stay in the pipe. If it's too steep, the water will get through real fast, but it won't be able to wash the paper and the poop and everything else with it. That 1/4 inch per float or per foot, that's our happy space right there. And we'll have all the waste material flowing, and all the water will go ahead and get that out of the house where it comes to it. So 1/4 inch per foot. And we run into this with heating, with venting, and also with our plumbing waste lines. So the drainage, 1/4 inch per foot down. Our vents, 1/4 inch per foot up where it comes to it. So we want the warm sewer gases to go up, and we want the wastewaters to go down. Some other terminology, I'm going to ask that you take a few moments and write some of this stuff down. Anything that goes up and down is called a stack. All right. Anything that goes horizontal, we're going to refer to it as a pipe. Depending on what flows through that stack or that pipe gives it a few other names. If it's poop or solids of any type, such as what's coming out of the toilet, we're going to use the term soil. So anything that flows horizontal out of the toilet is our soil pipe. Anything that goes up and down and solids flow through it is our soil stack. The term waste gets used for water only or liquids only. So if it's a kitchen sink or it's only a slop sink or a laundry sink, those are waste lines. All right. So it's either a waste pipe or a waste stack. Anything that's horizontal is a waste pipe. Anything that's vertical is a waste stack. And then we also have air flowing through those pipes as well. Now, if it's only air, so these are the pipes that go up and out through the roof, those are going to be vents, all right? So typically it's going to be a vent stack There is some configurations, and I'll show you some pictures in a little bit, where we can have a vent pipe coming in there, so it'll be horizontal run. But for the most part, we're going to be dealing with vent stacks. That means no solids are expected to flow through that pipe. No water is expected to flow through that pipe. Only air. And typically that's to let air into the system so that we would prevent a siphon from occurring on our waste lines and also on our soil lines. So as we look at this picture here, we can see the toilet on the right, and we have our slope going down and away. That's our soil pipe. The sink that's on there as well, that ties into our soil pipe. And then if you see the stack that goes up on that stack keeps going up and down so that where it lets water and air. So it actually has two purposes between the sink waste pipe and the soil pipe. That has a distinct name to it, and we're going to call it a wet vent. So it's designed to vent the toilet, let air come in there, break the siphon, but it still allows water from the sink to go ahead and go down there. Now, it's not the main vent stack. It's a branch vent, which is commonly the term that we're going to be using here. But in all reality, the part that goes up and down above the sink, that's our vent stack. And the part that goes horizontal up in the roof rafters or the ceiling joist, that's going to be our vent pipe. And then it goes into our vent stack that goes up and out of the building. Same thing here, just a little bit closer up to it. The wet vent, we're venting the toilet, and that's what we're assuming is present on the right side of that pipe where it goes. So if we allow water to come through it and air to come through it, that is a unique name of a wet vent. Cleanouts. This is common sense, kind of, all right? The sole purpose of these cleanouts is going to be to get a rod or a jetting machine or a rodding machine in there. In case there's a clog, I could get something in there and spin it and free up that clog. And this one's, roughly about 10 inches before I hit that concrete wall. And if I have to get that cap off and get in there and put a rodder in there, maybe a good plumber can do it. I don't know. But usually you want to give them at least 1.5 feet to do it. And they may never have to go into that spot, but that's definitely not a usable spot. Now, if I'm doing a home inspection and I see this, I cannot justify somebody making a change to it. But I might have a conversation where that if it does need to have happen and the plumber has to get into this one, there's nothing wrong with putting a 90-degree turn on it and bringing it towards us. At least that way it makes it accessible and usable where it comes to it. But I wouldn't do anything like that until the time comes that the plumber has to get in there. So I don't want to have the ownage on this one. I want to make sure that my client knows I saw it. So we're going to photograph it. We're going to document it. But this is one of those things where I'm just going to say, I just can't tell you to take any action or do anything about it. And if somebody disagrees with me, shoot out there. I'm cool with that. That's just my 2 cents. Here we got our galvanized pipe. We have cast iron fittings in there as well, going into our steel for our trap, and everything comes through. The problem with this one is, we're above the crown weir. So as we look at that stainless, I'm pretty sure it's stainless. It just might be thin steel on there, or yeah, it's probably just coated steel on the bottom of there, coated copper. But as we look at the bottom of that where it goes down and I got that U shape and then it comes over and turns towards the back, where it turns towards the back, that's the weir of the trap, all right? That's supposed to go straight into the wall. But instead it turns back up again and then it turns right and goes into the wall. So in all reality, that everything that's level with that pipe that's going out of the right, everything that's level with that is going to be filled up and held with water. It's just going to start creating problems with drains, low water flow, clogs, everything else that comes with it. We should try to get rid of the extension and bring it up there. But again, I think this is going to fall under. Listen, I want you to be aware of it. I want you to know that it might be problematic, but as long as it's flowing and water's coming out of there and it's not siphoning, and I would definitely check it for siphoning. These are the ones that I get aggressive on. And what I mean by aggressive is I will fill up those sinks, both of them, and I'll get them at least halfway filled up with water. Then I'm going to pull the drain on both of them and see if they drain equally, A. And then when it's done draining, to see if I start hearing gurgling sounds. If I'm hearing gurgling sounds coming out of this, then I'm not venting properly. I'm creating a siphon. That gurgling sound is siphonage that comes out of there. And if that's the case, and I have the ability, and there is a possibility, I can't guarantee it will, but if I have the possibility that I could siphon out that trap, then I'm going to leave it open with air. And if I leave it open with air, I could get sewer gases coming into the building as well. And I think I would be remiss if I would be doing you a disservice if I stopped right there. Just because a trap gets siphoned out is not the end of the world. But we don't want to own it either. We don't want to be paying to have it done right. So we're going to talk to our clients, and we're going to let them know the worst case scenario. You turn the water on again, run it slower, fill the trap back up again, and this way we could prevent those sewer gases from coming into the building. I just want them aware that it could happen. Same thing with S-traps. Underneath sinks are big problem areas. I can't push it enough. And often I find that sellers of a home, they store a lot of stuff underneath the sink. And it may have leaked, it may have been damaged, and they'll just put either another board down there or they'll put a piece of plastic on the floor there. I know it's tedious. I know it's annoying. I hate doing it. But it's kept me away from a bunch of complaints because eventually it's going to happen. All right. Pull the stuff out of there. Look underneath any sort of plastic. Look for any sort of past damages and document it. I don't care if it's dry today or not. In fact, the state law says water damage, past or present, we have to document it. In this situation, look for it. Because when they move out and they take all that stuff that's underneath there and they take the plastic that's underneath there, and now our client moves in and they're going to look at this water damaged floor of this cabinet, and it's just going to be a punch in the stomach, and they're not going to like it. But if we tell them ahead of time, it softens the punch up. It's easier to take that type of bad news, and even if you're not going to do anything about it, it's just easier to take that type of bad news when you're excited about getting the house. But after you're doing the moving, and any of us that remembers about moving, you're usually not in a good mood when that's happening. So when you end up seeing the damage to the floor, then it's going to be a few colorful metaphors, the word Charlie, and why didn't he tell me about this? So let's try to avoid that and be aggressive underneath the kitchen sink, bathroom sinks, anywhere where it's common that these things have leaked.